Hi everybody, welcome to your video lecture for week 7. We're going to do 3 videos and what we're going to focus on is Introduction to Algebra. And how we'll do this is I'm going to go through this lecture packet with you and I'm going to assign some homework from each video lecture and you can come into the following class with any questions that you have on that homework. So if you'd like to, if you want to pause for a moment and print out the lecture packet that is included in your week 7 Canvas course modules folder. That's the lecture packet you see here and the one that we're going to be working with throughout this entire video series. Okay, so if you're ready, what we're going to do is we're going to jump right into Introduction to Algebra. And our first focus here is going to be talking about sign number rules. Now, one thing I want you to know is that I want you to absolutely use your calculators to validate and check your work, but it's important that we understand the theory behind these rules that we use in algebra. And these are really our arithmetic rules for sign numbers that give us the power that we need to perform algebraic functions properly. So when it comes to addition rules, the rule is that if we have two numbers that are being added together that have the same sign, basically what's going to happen is their absolute values are going to increase. If we've got two positive numbers, like we see here, well, they're going to become more positive. If we've got two numbers that are on the left side of 0 on the number line, well, they're going to increase in the negative direction and hence continue to be negative. So the rule for same signs is that we add the absolute values of the numbers and keep the sign. And if you remember, the absolute value of a number is the distance from that number and 0 on the number line. So the absolute value of 3 is going to be the same thing as the absolute value of negative 3. So what we can do is when we have same signs, if they're both negative, ignore the signs, add the magnitude of those values, and then make sure to bring your negative sign along for the ride. Different signs work, well, they work differently. And the reason for that is because they're working against each other. If you think about negative 5 plus 2, well, negative 5 is 5 units to the left of 0 on the number line. Well, if we add 2 positive units, we're moving 2 units to the right, but we haven't crossed 0, so our answer continues to be negative. And notice the relationship between this and subtraction. They're working against each other. So what we're going to do is use that rule. We're going to subtract the absolute values of the numbers. So in this case, 5 minus 2, subtract the smaller from the larger, and then keep the sign of the larger number. Since 5 is larger and it's negative, then when we add up these two values, we expect our answer to be negative here as well. Take a look at this one. So we have a positive 12 being added to a negative 3. And notice if we use this rule, 12 minus 3 is 9, and it's going to stay positive because our largest value is positive. So here are our rules. For addition rules, when we have same signs, we're going to add the absolute values together and keep the sign. For different signs, we're going to subtract those absolute values and keep the sign of the larger number. All right, so let's move on. So a couple things to note before we start looking at other rules. It's important to know the difference between subtraction and indicating a negative number in your calculator. So I picked 2 common calculators that we've been using in class, and any variation of this really holds the same rules. Notice that when you're going to write a number like negative 7 minus 4, let's say, you're going to use this as your negative key, and this is only used for subtraction. There are a few calculators that can violate this rule, but most of them stick to this. So we're going to talk about how we can solve something like this in a moment using theory, but I do want you to be able to do this stuff in your calculator. So if you try it now, you should receive an answer of negative 7 minus 4 equals negative 11. And it actually relates back to addition if we think about it. Negative 7 minus 4 is really the same thing as negative 7 plus negative 4. And we can see here that that would also equal negative 11. And that's because we add the absolute values of 7 and 4, because we have same signs, we get 11, and we keep the sign. Negative 11 is our answer. So you can validate that on your calculator just to make sure that you've got that down. On the TIs, it pretty much works the same. If you take a look here, here's your negative key, and here is your subtraction key. All right, so let's move on and use these tools to help us on our way. So when it comes to subtraction rules, subtraction is a little bit more work than addition and can be a little bit more challenging. So what's been found is that, just like we've talked about in the past, when we divide, it's the same thing as multiplying by the reciprocal, and we can rewrite division of fractions in terms of multiplication to make life easier. Well, we can do this with subtraction as well. So we would use these techniques that I'm going to talk to you about if we weren't using the calculator to perform these functions. If we had to do this manually, notice that anytime we subtract a value, it's really the same thing as adding the opposite. So subtracting a number is the same thing as adding the opposite. Kind of like how division is the same thing as multiplying by the reciprocal. Excuse me. So here, instead of flipping the number, we flip the sign. So if we take a look here, notice that -5 minus -2, we're looking at this set of equations right here, can be rewritten as -5 plus +2. Subtracting -2 is the same thing as adding a positive. So now we can use our addition rules to solve this. In fact, we know that if we have different signs, we can subtract these values from each other and keep the sign of the larger number. Well, 5 minus 2 is 3, and since 5 is larger and negative, our answer will be negative. And that's why we see an answer of -3. Now, looking here, you can also see that when we have subtracting a positive, it's always the same thing as adding a negative. So in this case, we have -5 minus 2, which is really the same thing as -5 plus -2. Same signs here, which means we can add up these magnitudes. 5 plus 2 is 7, and keep that sign. So our answer here is -7. Well, when we are working with subtracting positive values, we can always jump to rewriting as adding the opposite. And notice that regardless of whether we're working with numbers that continue to be positive or dip into the negative number system, the rules remain the same. We could take 5 minus 2 and rewrite it as 5 plus -2, adding the opposite of 2. Using different signs, subtract and keep the sign of the larger, there we can see that we get +3. So I hope you appreciate these rules, but I do want you to know once again that you are absolutely welcome to use your calculators to validate these results, especially when we start combining like terms and solving equations. You want to be focusing on the algebra, not so much the arithmetic. But having a better understanding of the arithmetic will make you stronger in this area. Okay, so going into multiplication and division rules. Notice that I've always said math is evil. 2 wrongs always make a right. Well, anytime we multiply a negative to a negative, we get a positive result. And the same thing is true for division. Since multiplying by a number is the same thing as dividing by its reciprocal or vice versa here, well, since signs don't change in those cases when we rewrite as multiplying by the reciprocal, then we would expect that the product of 2 negative numbers would be positive, and the quotient of 2 negative numbers would also be positive because of that rule. If we have negative times positive, our answer will always end up as a negative result, and the same being true for division. And it's beautiful here, nothing changes. The world we've already lived in, living in positives, will always yield a positive result in this case when we're talking about multiplication or division. All right, so now what I want you to do is take a moment, pause the video, and try these problems. Okay, so let's take a moment here and look at what the results should be. You should have gotten 1 as your result for the first one. If we were to use the rule of rewriting as adding the opposite, notice that -7 minus 8 is the same thing, or excuse me, -7 minus -8 is the same thing as -7 plus the opposite, which would be a +8. Using different signs, we subtract the magnitudes here. 8 minus 7 is 1, and we keep the sign of the larger number, which is positive, so we get a +1. Looking at the next problem, you should be getting an answer of -45. Excuse my handwriting, guys, I'm lefty here. And here, just something to note, if we Remove common factors, we're left with 5/7. If you estimated this to a decimal, that's fine as well. Here's the kicker. Your decimal should be negative because we have a positive divided by a negative. And the way that we tend to write this is with that negative sign outside of the fraction, or we put the negative sign in the numerator. This is what's considered to be a simplified fraction. I don't really know why that's so significant, but it is significant in mathematics. So this is actually considered to be unsimplified at this point, simply because that negative is inside the denominator. A little silly, I know, but still the case nonetheless. So math is evil, 2 wrongs make a right, negative times negative gives us positive. So when we take the product of these two numbers, we yield a result of positive 12.375. Now, if any of these answers don't work out for you, make sure to bring this packet with you or your notes, if you're taking notes, with you to class on Friday, week 8, so we can review this together. All right, now, a little bit more challenging is working with negative values when it comes to exponents. If we come back here for a moment and just take a look at the calculators, every calculator has an exponent key, and it may be different based on the calculator itself. But if you notice right here, that is your exponent key. This key right here is x squared. It's a shortcut key for only squaring values. But if we're concerned with raising to any power, we use this key. It looks the same here. You may also see a key that looks like this, and that's also considered to be an exponent key. Every now and again, some calculators, the more fancy calculators, the more fancy calculators have a button that looks like this. That's also an exponent key. When you hit this button, you're going to put your base here, and usually you have to hit the right arrow or up arrow to get up into that exponent field, and hit the right arrow again to get out of it. So just be cautious there. And now let's try these problems together. So if you could come back to this slide right here for example 2, what I'm going to do is, or I ask you to, is to pause the video here for a second and try these problems. Okay, so let's take a look at the results here. Notice that our first answer should yield a value of negative 32. Now notice that it's really important that if your base is in parentheses, that you include parentheses in your calculator. If we look at this guy here and we try this one, notice we get the same result, negative 32. So it's almost deceiving, like it wouldn't give us a different answer. But when you try, when you try this value right here, notice that you're going to get a positive result. In fact, you should be getting a positive 81. If you put it in the calculator like this, then your answer is going to come out as negative 81. There's a significant difference between these. Here, we're telling the calculator to take the base of negative 3 and raise it to the 4th power. So if you think about it, that's 4 products or 4 factors of negative 3. And that would give us negative 3 times negative 3 is 9, times negative 3 is negative 27, times another negative 3, which is positive 81. When we write something like this, we're really telling the calculator to do this, because remember, it's following order of operations. And this is what we're getting. And we can see that would yield a negative value, because, please excuse my dear Aunt Sally, we would apply our exponents first before multiplying by negative 1. So if you tried the next problem here, you should be getting a value of negative 2, and that's because this gives us negative 32 divided by positive 16. Now, in the next one, make sure you're using parentheses when you should. And if you've done this correctly, your answer should be negative 0.0336. All right, so now that we have all these tools and techniques for sign numbers, we're ready to talk about some algebra here. So in this next section, we're going to focus on the distributive property. And what the distributive property says, while it looks very innocent in nature, it's actually a very, very powerful property for us. It says if you take an outside factor and you multiply it to some inside expression, then you're basically just multiplying that factor to each term in that expression. which means we can jump right to this statement. A times the sum of B plus C is equal to A times B plus A times C. So what that allows us to do is remove parentheses when values are grouped together. And you can see that it works here. Excuse me. If we look here and follow order of operations, we do what's inside the parentheses first, and negative 3 plus 7 is positive 4. Now we would multiply by that outside term to yield a value of 8. Well, if we take that outside factor of 2 and multiply it to each inside term, we're going to get negative 6 plus 14, and when we add those together, we also get a value of 8. And this also works for variables, because remember, your variable is just representing some unknown quantity. We don't know what it is until we're given a value for that variable, or for when we solve for it in equations, which we're going to be doing in the next video. So notice this problem right here. There's two ways to do this. We can follow this rule to a T and say, okay, the first product is 5 times 2x. If we look at the next one, we're adding a positive 5 to a negative 8. Notice that if we're doing this out, that would give us 10x plus, negative 40. Well, we know that adding a negative is the same thing as subtracting a positive. So we can jump right to subtraction if we want to. The way I look at this problem is 5 times 2 is positive 10x when we include the variable. And then here, notice we're multiplying a positive to a negative. So we're going to be subtracting that value. So it's going to be minus 5 times 8, which is negative, or minus 40. These mean the same darn thing. So it doesn't matter which way you express it. And if your solution set says one versus the other, know that either case is correct and you are free to write it any way you feel fit. Before we take a look at some examples, there's something that we just need to talk about. And that's the fact that we're going to be multiplying some variables together. Well, anytime we take something and multiply it to itself, we get x squared. Well, what happens if we have x to the third being multiplied to x squared? Well, if you think about it, that's the same thing as x times x times x. And that's being multiplied to x squared, which can be written as x times x. Now what we have is x to the 5th power. So a general rule here is that anything raised to a power, if we multiply common bases, so they have to have the same base, raised to powers, what we're going to do is simply keep the base and add the exponents together. And that's exactly what you see here. X cubed times x squared is x to the 3 plus 2, which is x to the 5th. If you have something like x times y, don't forget that y is being multiplied to this entire product. So it's also going to come along for the y, even though it's got nobody else to multiply to. It is still being multiplied to x squared. All right, so let's jump in and see how this all works out. All right, so now what I want you to do is take a moment, and I'll pause myself here for a second, and I want you to work through these 4 expressions. Now remember, these are expressions. You should end up with the same number of terms as you see in the parentheses. You are not solving anything. You're just rewriting this expression with these parentheses removed. That's known as the distributive property. All right, take a moment. All right, so let's take a look at these together. So if we look at the first one, we have a negative 7 times positive 3x. So using the distributive property, we have negative 7 times 3x plus negative 7 times 4. And when we do the math on this, whoops, excuse me there, that's going to give us the result. That's going to give us the result of negative 21x plus negative 28, or we can write it as minus 28. And that's the answer for the first one. Now, we can jump right to it. If we look at this next one, we have, thinking about the numbers first, we have 3 times 4, which is 12. And we have x times x, which we just discussed is x squared. Now I'm going to jump right to it. Notice that we're taking a positive and multiplying it to a negative term. And we know that positive times negative equals negative. So I'm going to jump right to subtraction and now deal with the values. So we have a 3x being multiplied to 3. 3 times 3 is 9. And even though that x has nobody to multiply to, it's multiplied to the 9. So it comes along for the ride. Now this one's interesting. Notice that this is really the same thing as negative 1 times 3y minus 5. So all we're doing is changing the sign of each individual term because everything's being multiplied by a negative 1. And this is going to give us an answer of negative 3y. Negative 1 times negative 5 is positive, plus 5. So these are our results so far. And do bear with me with my writing here. Sorry to be a lefty on this tablet. So now if we look at the next term here, this next expression, I'm going to take this one slowly. So I always used to play the game Saturday Night Live. Sign, then number, then letter. We have 3 times 5, which is 15. Now let's go to the next variable. We have x times x, which is x squared. And y has nobody to multiply to, so it just comes along for the ride. Now, positive times negative means subtraction. So let's start with the numbers. We took care of the sign. 3 times 2 is 6. Now the letters. X times x is x squared. Times y, which is y squared. So that's our final result. Like I said, if you have any questions with some of these and you'd like to see them worked out in class, just make sure to star them in your packet or on your notes, and we'll review them together. Now, our last part of this first video is section 3, combining like terms. What we're going to do in the next video that will be posted later in week 8 is use these strategies to help us solve some equations. And we're going to focus on equations that contain 2 variables. Oh, I just lied to you. I'm sorry. Equations that contain 1 variable and can be solved for that 1 variable. No exponents or anything like that. But we will be looking at formulas and they may contain exponents. So for that reason, we need to talk about like terms that not only involve variables, but also involve variables containing exponents. So think about it. When you add things together, like for instance, let's say we have negative 17 of this, plus another 3 of this. It would be negative 17 plus 3, which is negative 14 of this. Notice that what we do when we combine like terms is we look for the terms that contain the same variables and have exactly the same exponents on those variables. Once we know that, all we simply do is add their coefficients, and the coefficients are the numbers that are in front of those variable terms. But we keep the term the same. We don't square it. We don't add exponents. And the reason for that is, imagine you have, I don't know, 2 smiley faces. I'm going to do smiley faces because I'm not very good at drawing. And let's say that we added another 3 smiley faces to the mix. Well, how many smiley faces do we have? We've got 5 of them. So for that reason, we wouldn't want to say 5 smiley faces squared. That'd be a little weird, wouldn't it? No, so we're going to get rid of that exponent. So when we combine like terms, the only thing that changes is the coefficient in front, not the variable or the variable term itself. And you can see that here. So when we have an expression containing like terms, we figure out which ones are like. Notice in this case, 3a cubed and 5a cubed, and we add them together. 3 plus 5 is 8. So that takes care of our a cubes. But we're not done because we still have to subtract this 6a squared. Even though there's nobody to combine with it, it's still a part of this expression, and the expression would remain changed if we didn't include it. Notice, once again, we're not solving for a variable, we're just rewriting these expressions in a more concise form. And this becomes really important in a lot of applications. If we didn't do this, then applications on your smartphones would take years instead of seconds to process, because a lot of those things are built based on algorithms. And also your formulas. Imagine having to solve a Fahrenheit to Celsius formula, let's say, or convert from Fahrenheit to Celsius using some long laborious equation based on how it was derived. Instead, we want to say it as concisely as possible. Keep it simple, keep it sweet, keep it short. So we're going to take a look at this one. Notice that when we have parentheses, we have to distribute before we can combine. So in this case, notice that negative 3 times the expression 7xy minus 11y squared is equivalent to negative 21xy plus 33y squared. So we've distributed and removed these parentheses. We're going to do this over here as well. We're subtracting, so be careful of that sign. Negative negative is a positive for x times y. We tend to write them in alphabetical order. It's easy to combine them. That's why you don't see y times x here. And then we have negative times positive minus 6 y times y, or y squared. So now when we combine all of these terms together, negative 21 plus 4 is negative 17. 33 minus 6, because we have two y squared terms here, is positive 27. So our final result is negative 17xy plus 27y squared. All right, so now it's your turn. This is our last example, and this gets us through part 1 of your first Intro to Algebra worksheet that will be due for Friday of week 9. And this part 1 itself, will be due for Friday of week 8, so that you can get any questions you need answered or ask anything that you just need clarity on, so that you can work through this entire worksheet by week 9. All right, let's do what we've done before. Let's pause it for a second and take a moment to work through these expressions. Okay, we're ready to go. So if we look at the first example that we have here, we've got x terms and y terms. So I'm going to start with these x terms because these are like terms. They both contain an x, and the x has the same exponent, which is exponent of 1. So now what we're going to do is add their coefficients together. 5 minus 7, notice that that's a minus there, or 5 plus negative 7, that gives us the same result, is going to give us negative 2. Now we're going to make sure we bring that x, because we're talking about having negative 2x terms. All right, so we killed these. Notice that these guys are not like terms, so what's going to happen, excuse me, sorry about that, is we're going to bring these guys along for the ride. So we're going to end up with negative 2x plus 2y plus 12, and we're done. It feels natural to get down to one numerical answer, but remember, these are algebraic expressions. The only way you could solve this is if I told you what value we have for x and y. Then you could substitute them in and solve this and evaluate to get a one number answer. All right, so the next one a little bit more tricky, so we'll take our time. If we look at the first terms, it's x squared y. So we have 2 minus 5, which is negative 3, x squared y. All right, we took care of those guys. Now notice, we could jump to the xy terms. I'm going to go to xy squared because we tend to write our terms in terms of highest exponent to lowest exponent. And if you don't, and your solution shows your expression written a little bit differently but containing the same values on those terms, don't worry about it. Your answer is just fine. So here we have plus 10, 6 plus 4, x, y squared. Now we still have this minus 3xy. Oh, let me kill these guys. And this positive 6xy. So negative 3 plus 6, or easier, 6 minus 3 is 3. So it's positive. So we have a plus 3. Whoops, let me write it here. Plus 3, sorry about that, guys, x, y. So here's our final result. Negative 3x squared y plus 10xy squared plus 3xy. Now, in these two examples, the last thing we have to do, or I should say the first thing we have to do before we can get going, is distribute. So I'm just going to write them out here. So notice, if we distribute that negative 3, it gives us negative 6x, negative negative, which is going to be positive 12. That's our expression now worked out without parentheses, plus 2. So now we can clean it up. And this one's pretty easy because the only thing we have to clean up are those constant values. So we have negative 6x plus 12 plus 2, which gives us plus 14. All right, last problem of this video. And I apologize for the length. here, but this is still shorter than our lecture would have been in class. So here we have 4x, going ahead and distributing first, plus 4 times 3, which is 12. All right, we took care of that first expression. Plus, now we have that 5 being multiplied to 2x, which is a 10x. And we have 5 times negative 6, which is minus 30. So now what we're going to do is put our pieces together. We've got 4x plus 10x, which is 14x. Okay, those like terms are all set. Now we have 12 minus 30, which is a negative 18. And there we have it. All right, guys, so this takes you through. Now, notice that we have more sections to go. This section 4 will be covered in the next video, video 2. And our last section, after covering this, we'll be working with formulas. That's really what we're trying to get to. And that will be your video 3. And this will be posted, I believe, early week 9, so you can work on it throughout the week and have your work ready and any questions that you have ready for week 10. We have lots of time to review before we move on to our final exam. All right, so just a recap here. I'm going to go ahead and discard those annotations, those sloppy values that I just wrote there. Hopefully you could read them okay. And I just wanted to show you guys where you can go to work on your homework. If you go to week 7 alternate assignments, your first assignment is to take the Intro to Algebra and Solving Equations homework worksheet and complete part 1. And you can access this right in Canvas. And if you click here, you can see what you'll be doing here. You're going to be doing part 1, which is essentially just the first page. Part 2, like I said, this will be after video 2, and you can check your work. The solutions for these values, especially if you want to move ahead, are right here for you, so you can be validating your results as you go along. Now remember, I want you to work on this so that you're prepared for Friday of week 9. Excuse me, I just lied to you. The second lie. Friday of week 8, so that you can come in with any questions that you have. Now don't forget, we go to our assignments here. We go back here. We should also have, if you haven't passed it in already, units 28, 44, and 45. That was due week 7, but you can certainly pass it in week 8. Those of you who have passed it in earlier, I really thank you for that, and I will get those graded and back to you by week 8. If you have a lot of questions, hold on to it and just bring those questions with you week 8 so we can solve them first. Thanks for your time, guys. I hope you found this